String theory with real string. String theory is the theory where particles such as electrons, quarks, and photons are replaced by one-dimensional strings. The string's vibrational state determines its charge, mass, and other properties. Strings are so small that they look like particles until you zoom into the Planck scale, 10 to the negative 35 meters, or 0.00000000, well, you get the idea. It's really small. We typically see the world in 3 dimensions, and you may know that the 4th dimension is time, but string theory needs even more dimensions than that. 10, 11, or 26, depending on the version of the theory. So where did all of these extra dimensions go? To answer that, we need brains. No, not that kind of brain. This kind. It's short for membrane. Technically, everything is a brain. A particle is a 0 brain, a string is a 1 brain, and a membrane is a 2 brain. The most important class of brain is the D brain, short for Dirichlet brain, which satisfies the Dirichlet boundary condition, a condition that applies to all differential equations where the solutions of the equation must have fixed values along the boundaries of the equation's domain. For example, let's say you're breeding flies, and for every 2 flies that you have, a new fly will appear the next day. To model this using a differential equation, you write that the increase in flies equals the rate of change of the amount of flies times the amount of flies. So if you have 4 flies, you'll get 2 more, and if you have 6, you'll get 3. These are fixed numbers on the domain of the function. You can't get a different result when using the same values, and you can't get a number that's completely outside the graph. So this would satisfy the Dirichlet boundary condition. D-branes are mathematically consistent, and they give us a way to account for all this extra dimensions using a theory called brain world cosmology, which says that the entire observable universe is trapped in a giant 3-dimensional D-brane, and the other dimensions are only available in other branes that we can't access without moving at a right angle to reality, which is impossible. But before you start worrying about extra-dimensional aliens coming to invade the galaxy, you should know that this theory is impossible to prove and pretty unlikely. If we could only see a tiny fragment of the real universe, surely we'd know, right? Right?